Hello students. Today we discuss mass and weight. First, mass. Quantity of matter possessed by a body is called the mass of body. It is represented by a symbol small m. It is a scalar quantity and mass of body is measured by a beam balance by comparing the mass with bodies of non-mass. Second is weight. The force with which a body is attracted towards the center of earth is called the weight of body. It is represented by the symbol W. Expression for weight is given by if mass of body is small m and acceleration due to gravity is small g, then weight of the body is given by W equals to mg. Its SI unit is Newton and it is a vector quantity having direction towards the center of earth. Now, the differences between mass and weight. First, mass and weight. First difference is mass is the quantity of matter possessed by a body and weight is the force with which a body is attracted towards the center of earth. Second difference, it is a scalar quantity while the weight is vector quantity. Third difference, its SI unit is kilogram. On the other hand, its SI unit is Newton. Fourth, mass of body is never zero. While weight of body becomes zero at the center of earth. At center of earth, W equals to 0. Fifth difference is mass is measured by beam balance. While it is measured by spring balance. These are the differences between mass and weight. Now, weight of body on moon. A body of mass m has weight W equals to mg. For Earth, we know the acceleration due to gravity Ge equals to 9.8 meter per second square, and for Moon, acceleration due to gravity Gm equals to 1.7 meter per second square. Hence, weight of body on the Earth's surface We equals to mge and The weight of body on the moon surface Wm equals to mgm. Now, when we find the ratio between Wm, which is the weight of body on the moon surface, to weight of body on the earth surface, we find Wm upon We, which is mgm upon mge, which is equals to gm upon ge, and when putting these values of gm and ge, we get it approximately equal to 1 by 6. So, we get the relation Wm equals to 1 by 6 times the We. Next topic is variation in the weight of a body. First point is, at a place, the mass of a body remains the same throughout the universe, but as the value of g is different at different places, hence the weight of body is different at different places. Second, the value of g is more at poles and less at the equator. Therefore, weight of body is more at the poles and less at the equator. Weight of body is more at poles while less at equator. In other words, a body weighs more at poles and less at the equator. Third point is, the value of g on the surface of different planets of solar system is different on different planets. Now, the next point is, the value of g decreases with height from the surface of Earth. Therefore, the weight of a body also decreases with height. Weight of body decreases with height. That is why the weight of a man is less on the peak of Mount Everest than the weight of man at Delhi. Next point is, the value of g decreases with depth from the surface of Earth. Therefore, the weight of body decreases with depth from the surface of Earth. Sixth point, the value of g at the center of Earth is 0. Hence, weight of body is 0 at the center of Earth. At center of Earth, the weight of body is 0. Now, the differences between small g, which is acceleration due to gravity, and capital G, which is universal gravitational constant. First, the acceleration produced in the body falling freely under the action of gravitational pull of the earth is known as acceleration due to gravity, while capital G, which is the universal gravitational constant, the gravitational force between two bodies of unit masses separated by a unit distance, is known as universal gravitational constant. Second, the value of G is different at different points on the earth, while the value of capital G is same at every point on the earth surface. Third, the value of G decreases as we go higher from the surface of earth or as we go deep into the earth. But the value of capital G does not change with height and depth from the surface of earth. It does not change with height and depth. Fourth point is the value of G at the center of earth is 0, while the value of capital G is not 0 at the center of earth or anywhere else. Next point, the value of G is different on the surface of different heavenly bodies like the sun, moon, the planets. Different on different planets. While the capital G is same throughout the universe. Throughout the universe. Last point, the value of G on the surface of earth is given by 9.8 meter per second square, while the value of capital G equals to 6.67 into 10 to the power minus 11 Newton meter square per kilogram square throughout the universe.